Good Monday morning to y'all. Got something for you today, a couple of diagnostic stories. That this particular thing, condition, cause, and correction, is the standard thing that that instructors are taught to teach, and basically a lot of your manufacturers at their schools, they teach this too, and it's a good way. The condition is your symptom, the cause is what's causing it, and the correction is what you did to fix it. And all those dots need to be connected, and if you go about it methodically, you'll typically find out what's wrong, go right to the problem, and it'll be fixed and it won't come back. Now, this RX-7 I talked about this a time or two, but I basically created a graphic this time to illustrate it. It kept wiping out the rear axle bearings out here at the ends. Out here, it would wipe them out. They'd replace them and wipe them out, and they'd replace the entire axle assembly, and it still wiped out the bearings. Well, it's obvious the problem was not the bearings or the axle; it was somewhere else. And this was one I heard about when I was in school with Mazda in Jacksonville, and it was explained in a way to where it was easy to understand. What happened when you went to start it? The power would go from since it had a bad ground between the battery and the block, the power would run down the drive shaft into the rear axle. It would go out here, when it arc on the axle bearings, come back up the park brake cables through the body, and the body ground was good, so it was getting its ground through the body by way of these axle bearings, and every time it arced on the bearings, it would make a little pit in the bearing. When you took the bearings out of there, you couldn't tell that's what was going on, but it turned out that all it took to fix that was to tighten the ground at the engine block that went to the battery. And that was, that's one of those things where the condition caused correction. And what happened with this was the dealership finally gave up on it. Mazda bought it back, sent it to us, the training center for a trainer car, and the instructor found the problem, which I thought was very interesting. That all of that got put together after it went through all those hands. You can see how that would work, though. This 98 F-150 came in with an illuminated malfunction indicator light. We had done several different jobs on this vehicle off over the years. The guy had inherited it from his grandfather, and he was just having it first one thing and another fix. One of the things he had us fix, believe it or not, was the check engine light. Because he said he didn't like the check engine light not working, because he wanted to know if there was a problem. So we fixed the check engine light. Well, this one here had an illuminated mill. It had a new noise under the hood that it didn't have before. We didn't initially tie those together, but they were related. All right. So the the EGR system has to deliver exhaust gas in here. And the reason it puts the exhaust gas in there is exhaust gas is inert, and it doesn't burn as hot, so you don't make oxides of nitrogen by going over 2,500 degrees in the combustion chamber during the burn. Well, this EGR gas tends to flow through here and pile up sludge, and it'll clog up the port where the EGR is supposed to go in under the throttle body. So I don't know how many times we had to clean that junk out of there. That was just a fairly common thing, and on a lot of different vehicle makes too. It's not just a Ford. Chevys will do it too. This DPFE sensor was basically, there was an orifice here, and whenever you got gas flowing through here, this pressure is going to rise on this side, and it's going to drop on that side. So it would compare these two pressures, and it could tell how much EGR flow you had. Of course, the EGR was controlled by this vacuum regulator that's hooked to the engine controller. So I said, initially I was thinking, well, the P0401 means there's no EGR flow, which means this is not changing when this valve tells the EGR to open. This is either stuck, or there's something else going on, or usually this will be clogged up. That wasn't what was wrong with this one. What was wrong with this one was this EGR feed tube, see, comes right down there off of the driver's side manifold, right in front of the header pipe. And it basically, and there's those two pipes going to that DPFE sensor, and there's your EGR valve. So this is what the pipe looks like when you buy a new one. And it's got a little thing here where it's the little orifice is right in between those two pipes right there. And it turned out, and I've shown you this picture before, this bolt had rusted out. This had dropped back. There wasn't enough pressure because it was right above this where the EGR gets its pressurized exhaust gas. It only recycles about 5% of the exhaust gas, by the way. And only when you're driving down the road. It never does it idling or it'll idle rough. So I didn't have time for this because we were right at the end of the semester and I didn't want to go to the trouble to fool with all this. This is sort of a dicey situation because this truck was really old, and this right here would be a pain to fix. You know, get that thing drilled out and tapped and all that. I mean, it could be done, but it would take a long time. Taking the manifold off, you're liable to break the bolts off where they're going into the head, you know, because of the age of the truck and all. So they make things like this, and I've pictured them before, that you can buy on Amazon that will do the same job. I didn't know about this at the time. They may not have even had them then. But I got this plate that came from an air conditioner compressor, you know, that when you get that, this plate's bolted to it, it covers it up. And I brazed an Allen wrench to it, and I brazed a nut to the other side. And that Allen wrench basically was hooked over the top of this manifold here, and I tightened that screw up, and that pulled this thing right up there and fixed the noise and all that. And I figured, well, we'll fix this next semester because it's not going to last. But it did, and the guy's still driving this truck today with this same rig under there that I created. But I've shown you that picture before. Don't get too bored with it. This 2004 Envoy, the owner complained that the vehicle lacked power, and we did some basic checks on the low power concern. Focused on the catalyst. Now, I've had a forward-looking infrared camera, and I have one over here right now that I use at home for different things. Incidentally, don't get a forward-looking infrared camera and go checking around all your windows and your doors, because it'll make you sick about how much air is leaking in there, especially if it's an old house like the one we live in. But anyhow, this I could not categorically condemn the converter by measuring temperature. You know, I'm looking for a smoking gun, and if I'm measuring temperature and it's not giving me good information, then it's not 100% that you can measure temperature and find a bad catalyst every time. I've talked about that a little bit before. On this particular time, I took my trusty homemade tool, which is this 18 millimeter plug that came out of a new catalytic converter, you know, that's screwed in there to plug the oxygen sensor hole. A homemade tool, I put in place of the O2 sensor, I got is this much back pressure. 4.5 pounds is what I got. See, that wasn't enough to give me a temperature reading. In other words, if it's hotter in front of the catalyst, between the catalyst and the engine, than it is behind the catalyst, then that's your smoking gun there. It shouldn't be. This one wasn't. The temperature wasn't that much different, which really surprised me. But when we cut the catalyst out of there, this is what we saw. The catalyst had failed. Of course, you know, you had this crack right here. It was letting some air through, and there was a lot of holes that were unstopped, so it wasn't completely clogged. It was clogged enough though where the guy could tell a difference. Now, we bought a Walker catalyst to put in there. Now, the Walker makes a really good catalyst. Some of your aftermarket catalysts aren't that good, and they'll still throw you a code. And this is the catalyst. It's got the sensor on both sides of it, and it's two, you know. So, wait a minute. I'll take that back. It's let's see. Let me look at that. This is actually shown backward. Now here, this is the catalyst. Let me see. This was the light off catalyst. So yeah, there was an oxygen sensor on both sides of it. I want to make sure I was telling you the truth about that. It's been a while since we did this. But if you're ever cut an exhaust apart, or and you try to just weld it back together on the bench without making sure it's right, then you are going to wind up in a situation where your exhaust doesn't fit anymore. And so, having known about this for my entire mechanic's life, as long as I've been fooling with exhaust systems and stuff, we basically made doggone sure that we made marks before we ever cut the catalyst out of there. We made long black marks with Sharpies and numbered them and all that. And then we cut the catalyst out of there, and when we put the one back in there, we lined up those marks as good as we could. And we had tacked this in here. so that it would be like it was going to be, but it wasn't completely welded. And then we put it back up in there to make sure it would fit right. And when we made sure it would fit right, then we took it off and finished the welding job, and that worked really well. And he wound up with a new catalyst in there, took care of his whole problem. That was what we were after anyway. His 2003 B2300, the first symptom the guy noticed was when he was driving down the road, his AC airflow would gradually decrease to the point that while he could hear the fan, he had no air at the register. That was the first thing he noticed. The next thing he noticed was that he had to jump the vehicle off in the morning. Now, these two symptoms are related, but you have to kind of put this, sometimes you don't put this together until after you find one of the things that's wrong. You'll say, well, that's what was causing the other problem too, although you wouldn't have thought about it. But it made all the sense in the world whenever you finally figured it out. Now this guy right here, he checked the battery voltage before he jumped the truck off, and it was down around 10 volts in some state of discharge. To digress for just a minute, one of the salesmen at the Ford dealership where I work came to me, and he says, I don't know why he came to me, but he says, in the morning, my microwave, my coffee maker, nothing works the way it's supposed to in the morning. But during all the rest of the day, it works just fine. And I said, well, get you a cheap $10 meter, digital meter at the parts store, and hook it up to the wall outlet. It's not going to shock you because you're just easing those probes in there. Put it on 120 volts, or put it on the 200 volt scale so you'll be able to read. And I said, you want to know what that voltage is? Just leave it hooked up all night long, so you can monitor that voltage. And so he came back and he says, I connected it at night and it was 120 volts. The next morning, it was 105. And he says, and I said, well, that explains why you're not doing well. He says, well, I called the power company and I told them what I had found, and they said, well, your meter's not calibrated. We'll have to check it. And they put some kind of a device on there that would record the voltage at the various times of the day. I don't know, maybe even have a piece of paper that would go real slow, drawing lines or something. And he said, sure enough, in the morning, the voltage was low, and so they put a transformer in there and took care of his problem. But what we did here, let's see how to jump it off. Let's just see about a parasitic drain. Well, more than 50 milliamps is enough. He had 2.2 amps. I said, well, now that's going to be what's killing your battery. So while we still had this, of course, you need to, when you're hooking up one like this, I like using an inductive probe for this because you're not disconnecting anything. But on this particular truck, we set the meter on amps, and we hooked it up between the battery terminal and the battery cable with a lead in the amps measuring port, so that the juice that's going to whatever the load is was actually going through the meter, right? And so actually I'm showing these like you ought to hook them up. This is going to go to the most negative side of your circuit. That's going to go to the most positive side, which is battery terminal. So if you're going by the electron flow, the power would be going this way. But if you're going by conventional, it'll go that way, one way or another. I said stuff I didn't need to say there, but the point is we had 2.2 amps. But you need to wait 30 minutes when you first connect this thing and let everything get charged up, let everything shut off on these newer vehicles, because sometimes you'll have a bunch of draw that's there that will go away if you just wait a while. This one here never went away. So what we did was we started pulling the fuse. The fuse pulled 25 after we pulled the fuse. In other words, you start with your big fuses, then you go down to your little fuses. When you pull a big fuse that kills the draw, then you look at the little fuses it feeds and you pull those one at a time and you vector in on your problem like that. The AC clutch, we heard the AC clutch release. Well, the AC clutch was turned on all the time because the relay was stuck. Now this is the fuse we pulled on that B2300, and there's the relay right there. The relay, pulling the fuse, revealed the fact that the relay was a problem, and the fuse, this power was going through the relay to the AC clutch all the time. The clutch was always engaged. It couldn't cycle the clutch off, and driving down the road it would freeze up its evaporator. Okay, So we had a stuck relay. Yeah, that's something that happened. So when we pulled that fuse, there was no power going down here and the clutch released, and that's how we located that. Okay, so the stuck relay was the reason the AC evaporator was freezing up, and it was also the reason for the parasitic drain. There was another vehicle, it was a Dodge that we worked on that belonged to one of the students, and it was freezing up the evaporator, and we saw that it would only run the have the clutch energized all the time whenever the engine was on and running and all that. Well, it turned out on that one, it was the pressure cycling switch, the little switch that was out there, evaporator, it was stuck, and it was freezing up her evaporator. And so that was a similar situation. If that clutch doesn't release, or even if it's messed up or worn out to the point to where it's just mechanically held together, if it's spinning the compressor all the time, you're going to have a frozen evaporator and all. This is a short video, but I wanted to throw some bones to you guys today. I hope you have a good week, and I hope you turn a lot of hours, and let's all be careful out there. We'll see you next time.